Hello students. Our today's topic is total internal reflection in a prism. Take a look at the picture on the screen. You will find that these peoples are looking into some sort of instrument or a device. Now, what do you think this device does? First of all, let me tell you that this is inside a submarine. A submarine is a kind of ship that travels inside water or under the surface of water. Now, if these peoples are inside the submarine, what are they seeing exactly? You'll be surprised to know that. With this instrument, they are seeing things that are above water, whether there is any threat or not. If they are under the sea, how are they able to see above water? With the help of an instrument, and this instrument is known as periscope. Now you'll be wondering how this periscope works. Just have a look to this animation. In this, the ray is deviated with the help of prism. A ray of light passes with the two prism. This is how the prism looks like. Suppose this is a prism. Its one angle is 90 degree and the other two angles are 45 degree. That means it's equal to this side, hence it is an isosceles right angle prism. Now in this, consider, suppose a ray of light is coming from air to the glass and it passes undeviated. That means it is normal to the surface when it hits the glass. So it will pass undeviated and hit the point D on the surface BC. So as you can see, when we draw a normal to the point BC, suppose this red color is our normal. Okay, now this is our normal to the point BC. So first angle, that is BDO, is 45 degree. So again this is our 90 degree. So this will also be 45. This will also be 45. Now what happened? This ray, when strikes the prism, here the incident ray, the prism is made up of glass and its critical angle is 42 degree and the angle of incidence is 45 degree. So the angle of incidence is more than the critical angle, hence here total internal reflection will be occur. Total internal reflection will be there. Here total internal reflection will be there. So when light ray strikes at 90 degree, it passes undeviated. That is, overall this prism has turned the ray by 90 degree. Now, so whenever we are having a prism of 90 degree, 45 degree and 45 degree, a ray which comes and strikes it, and if that is perpendicular ray is coming and striking the surface from air to the glass, it will pass undeviated. Again it forms 45 degree of incidence at the point of another surface of the point, so which is more than the critical angle of the prism. So there will be a total internal reflection and the prism will, the ray will deviated by 90 degree. The ray will deviated by 90 degree and hence the surface offers total internal reflection inside the prism. So what actually it is doing? It is just converting the ray by 90 degree angle. So similarly it happens when we will consider two rays. Suppose in our book the diagram was given where two incident rays was coming and striking the surface. So this, you can see the real picture in which the ray of light is coming, striking the prism and hence diverting the prism by 90 degree angle. Now consider this diagram. Here we have two rays, P and P dash, which is coming and striking the surface AB, where ABC is a total reflecting prism in which angle B is 90 degree, angle A is 45 degree, angle C is 45 degree, this is also 45 degree. So what happened? A beam of light is incident. Now this beam is coming and with normally forming an angle 90 degree over here, so it will pass undeviated. it will pass undeviated. Now this is our normal. So this is our normal. What happened? This angle will be 45 degree. So this will also be 45 because this angle should be 90 degree. Okay. Here, so which is more than the critical angle of the prism? Therefore, this ray will form total internal reflection and it passes undeviated from this prism. Hence, what is actually is happening over here? It passes undeviated into the prism and strike the face AC at an angle of incidence which is equal to 45 degree. For the glass air interference, the critical angle is 42 degree. Therefore, the beam of light suffers total internal reflection at the face AC. Because the angle of incidence is greater than the critical angle, the reflected beam inside the prism then strike the face BC where it is incident normally and therefore passes undeviated. As a result, the incident beam gets deviated through 90. The ray is coming here, striking, deviated through 90 degree and it passes out from the prism. Okay, this is how the deviation of a ray of light through 90 degree happens. Now moving on to the next topic. For the second example, we'll take another same prism with 90 degree, 45 degree and 45 degree. Here we'll see the deviation through angle 180 degree. A ray is coming, striking the prism and hence 180 degree deviation of the ray is here. So the ray is striking the prism and coming out in the same phase from which it enters. So the deviation of the ray is 180 degree here. Now here what happened? Again the ray is going parallel to the prism. So it passes undeviated. It strike this surface. Here the normal is this. This angle is 45 degree because this is a triangle. So this angle 45. So this will also be 45. Since this is 90. So this angle will also be 45. Again, this is a angle of incidence is 45 which is more than the critical angle of the glass. This 45 angle is more than the critical angle of the glass. So the ray will pass undeviated. Again it strike this surface. Here also again same process. This is the normal. Okay, this is normal. This angle is 90 degree. So this angle will also be 45 degree. This was 45. So this will also be 45 degree. Hence this angle will also be 45 degree. So 45 degree which is more than the critical angle of the prism. So this ray will just pass out undeviated straight from the prism. Hence the ray which enters into the prism just comes out with a deviation of 180 degree. Yeah, the deviation of the prism is 180 degree. Okay, the prism was the same total reflecting prism with 90 degree, 45 degree and 45 degree. Suppose in the next diagram we have two rays. Here two rays means the object top and the bottom point. Suppose this is our object PQ. Okay, so it enters into the prism and comes out with a deviation of 180 degree. Same way. In this figure, the beam of the light from the object PQ falls normally on the face AC. Here, normally it falls. That means of the prism. So it enters undeviated inside the prism. So it enters undeviated inside the prism and strikes the glass air surface AB. This surface it strikes. Since the prism of the light is traveling from glass to air at an angle of incidence which is equal to this, so here at the normal, what happened? This angle was 45, so this will also be 45, hence this will also be 45. So here the normal will be, this is our normal, this is our normal, the dotted line, and hence it forms 45 degree angle which is more than the greater than the critical angle of the glass. Therefore the beam of light suffers total internal reflection. It goes and hit this surface BC. it goes and hit the surface, strike the surface BC at an angle of incidence. Again here also, suppose this is our normal, here also we'll draw a normal. So it forms an angle 45 degree, which is more than the critical angle of the prism. So again it suffers total internal reflection. The beam of light inside the prism now falls normally on the face AC, normally on, and hence it forms total internal, so it comes out normally from this face AC. This was the ray which goes, strike and comes out with a deviation of 180 degree angle. Now moving on to the next one. In this case, we'll just invert the image, to erect the inverted image without deviation. Okay, this is also a total reflecting prism. Again, this is also a total reflecting prism. Here, this angle is 90 degree, this angle is 45 degree, this angle is also 45. Now, the ray of light is coming from this side. It strikes here the surface. Now, this is our normal. This is our normal. So, this angle is 45 degree. So, this angle will also be, this will be 90 degree. Hence, this is the 45 degree angle. It goes and hit this surface here. So, moves away from the normal here, the ray, and it goes and strike this surface at this point. Again, this angle is now 45 degree. So, this here, when you draw the normal, this angle, the ray from the glass to air, it goes out and it goes away from the normal. And when it goes away from the normal, it forms a parallel beam of light with the incident ray. So, consider this with two ray of diagram. Suppose here in this diagram, here this is our object XY, which arrow you can see just here in the downward direction, and when we will get the image of this object, the pointed arrow you can see as it just inverted over here. Here only we will invert the image in this type of prism. This is called erecting prism. This type of prism is called erecting prism, in which we get inverted erect image. What actually happens here? The beam of light from the object XY is incident parallel to the face AB of the prism and strike the face AB of the prism. It suffers refraction from air to glass. Here we have air and this is our glass. So, here we will draw air to glass. Here angle of incidence of the glass is 42 degree and angle of incidence of the ray, and critical angle is 42 degree, and angle of incidence here it is forming 45 degree, which is more than the critical angle of the glass. Therefore, it suffers total internal reflection. The beam inside the prism now strikes the face AC. At an angle incidence less than the critical angle. Hence, it suffers refraction from the glass. When it strikes the face BC, again it suffers refraction because from glass to air it is coming out, and it bends away from the normal. The beam emerge out parallel to the face AC. This beam is parallel to this face, and as a result the refraction of the emergence of the ray are inverted, and for the inverted object PQ, the erect image is P dash, X dash, Y dash. In your book the image object is PQ, here it is X and Y. So, it is X dash and Y dash. Now, moving on to the next topic. Here we will consider a total reflection with a prism having each angle 60 degree, that is a equilateral prism. Total reflection with a prism in which each angle of the prism is 60 degree. That means this angle is 60 degree, this angle is 60 degree, and this angle is 60 degree. Our incident ray is coming, striking the prism. Here total internal reflection is also happening. Now let's consider how it happens. Now in this case, we have a prism of each angle as 60 degree. This angle 60 degree, this angle, hence this angle is also 60 degree. Can be used to deviate a ray of light through 60 degree by total internal reflection. Now in this figure, suppose a ray of light PQ. This is our ray of light PQ, which is incident normally on the face AB. On this face it is coming and incident normally. So this PQ is coming undeviated, that means it will pass straight and strike this surface at this point R. Okay, QR. So here we will draw this dotted line as normal. Okay, now consider this triangle. Now in this triangle, this angle is 90 degree, this angle is 60 degree. So this will be 30, this angle will be 30. Since this is our normal, this is our normal, this is our normal. Okay, so this 30, that means this angle will be 60 degree, which is 60 degree. Since the angle of incidence is 60 degree, which is more than the critical angle, this is our angle of incidence, which is 60 degree, which is more than the critical angle. Hence this ray will, in this prism we have total internal reflection. The ray RS obtained after total internal reflection falls normally on this surface. This falls normally on this surface BC of the prism. So it passes out undeviated through the face BC. Thus ST is the emergent ray. This ST is the emergent ray. This ST from the prism, and it is clear that the incident ray PQ has turned through an angle of 60 degree. Through an angle of 60 degree towards the base from its initial direction, and it emerges out at as ST. Once again, this ray was coming, this PQ, which is normal, so it will pass undeviated and it strike this point. After here what happened? Since this angle was 60 degree, this is our 90 degree, so this will be 30 degree. Now since this is our normal, this angle is 30 degree, so this will be 60 degree. 30 plus 60, 90. 60 degree, angle of incidence 60 degree, that means it is more than the critical angle of the glass, that is 42 degree. So we'll have a total internal reflection, and hence this ray will pass straight away from the prism ST. Thank you.